Okay, so let's work on verifying some of these identities. First thing that you want to do is work with the most complicated side. So we're going to pick our left side here, which is secant squared theta minus 1 over secant squared theta, and that equals sine squared theta. You can do this in several different ways. I noticed right off the bat that secant squared theta minus 1 comes from an identity. I know that tangent squared theta plus 1 equals secant squared theta. So it would follow that tangent squared theta would equal secant squared theta minus 1. So I can actually go ahead and replace that and say tangent squared theta over secant squared theta. And at this point, if I want to convert to things in terms of sine and cosine, it would make sense. So this is going to be sine squared theta over cosine squared theta divided by 1 over cosine squared theta. And dividing fractions, we flip and multiply, so we got sine squared theta over cosine squared theta equals, times cosine squared theta over 1. This is going to cancel, and I'm left with sine squared theta, which is what I had wanted to make that left side equal to begin with. So this is proof by using one of my identities and then just doing some simple math that I can get from one side to the other. Next problem. So we've got 2 secant squared alpha, but we'll just call it theta, equals 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. So the more complicated side is your right side. So we're going to make it want to look like this. So I'm going to work with my right side until I get it to that. So first thing I need to do is I need to add this together. So I'm going to get 1 plus sine of, I'm going to change it to theta, plus 1 minus sine of theta, divided by 1 minus sine times 1 plus sine. So I can further simplify this. So I've got the 1's would add up to make a 2, and then I would end up with nothing else. So I would just end up with 2. Because the sine of theta and the negative sine of theta would cancel. Well, the bottom, we would multiply this, and this actually factors out to be 1 minus sine squared theta. Well, remember, I'm trying to turn it into secant squared. Secant has something to do with cosine, so that gives me a hint that I need to turn this into something involving cosine. Well, I have an identity that says cosine squared theta plus sine squared theta equals 1. So it follows that cosine squared theta is going to be 1 minus sine squared theta. So I can go ahead and replace these. So I'm going to get 2 over cosine squared theta, which, if you remember, 1 over cosine squared theta is the same thing as secant. So this is, you can think of this as 2 times 1 over cosine squared theta, which is 2 secant squared theta. If we keep moving on. So we have here, we're trying to show that these two things are the same. So we are going to multiply this part out and try to show that it equals negative tangent squared. So if we have tangent squared of x plus 1 times cosine squared of x minus 1, well, what can we do here to make things easier on ourselves? Okay, well, I'm going to start off and say I actually have an identity that works with this, an identity that works with this. So let's take these one at a time. So I know that tangent squared theta plus 1 equals secant squared theta. That could be helpful. And I also know that sine squared theta plus cosine squared theta equals 1. So what I want to use for this is, well, this plugs in perfectly, but to get cosine squared theta minus 1, cosine squared theta minus 1 would equal negative sine squared of theta. So this is what I'm going to use on this side. Excuse me. So I could convert these to secant squared theta times negative sine squared theta. Well, secant squared is the same as 1 over cosine squared theta. And since this is negative sine squared of theta, this would stack to make negative sine squared theta over cosine squared theta, which gives me negative tangent squared theta. This is almost easier. It looks complicated, but it's almost easier than simplifying because you know what you're trying to get to. So you know that you need to eventually get down to tangent, which is sine over cosine, which means that I need to get stuff in terms of sine over cosine. So it's a hint as to how I need to go about problems. So then we got verify this identity. Now we might sit here and say, which side is more complicated? Is it this side or that one? Now, most people might pick the right side. Over here, they might see that this is more complicated. But in reality, every time I always say this, addition is more complicated than multiplication. It always makes things different. So this is the side that I want to work with, and I want to leave my right side alone. So I've got tangent of x plus cotangent of x. I'm going to try to make it equal to this. So obviously I need to start combining stuff. So this is the same as sine of x over cosine of x plus cosine of x over sine of x. So we need to do the method to add, right? So you're going to get sine times sine, which is sine squared. You're going to add cosine squared of x, and you're going to divide by cosine times sine. Well, the numerator, we know this always equals 1. That's one of our identities. So you're left with 1 over cosine x times sine of x, which you could think of this as 1 over cosine of x times 1 over sine of x, which this is the same thing as secant x cosecant x. So we know we're going to this point. So we want to add this side together. Once we add it, we can see that we have an identity on top, and then we just have to make it look like the other version. So we only work with one side at a time. Okay, so lastly, we're going to keep moving. Which side is more complicated? Hopefully you saw that when we do these additions, it does make things a little complicated. So we're going to work with the left side and try to turn it into the right. So secant x plus tangent x. So this is the same thing as 1 over cosine of x plus sine of x over cosine of x. So if we do the method again to add, we're going to get cosine of x plus cosine of x sine of x divided by cosine of x squared. So I'm going to want to factor the top, and I'm going to get cosine of x times 1 plus sine of x divided by cosine squared of x. Now, at this point, you may say, well, how is it that I get to where I need to go? This doesn't seem like you could cancel the cosines, but it doesn't really help you out here. What's going to help you out is this down here, this 1 minus sine of x. Well, where would 1 minus sine of x come from? That's going to come from the factor like this. So if you remember, the difference of squares factors in this way. The fact that I have a 1 plus sine of x means that, well, there must be a 1 minus sine of x somewhere. So I need to figure out a way to connect 1 and sine together. Well, here's my ticket. Cosine squared. Cosine squared, based on the Pythagorean identity, always equals this. And so what I have here is this situation to where I can actually think about this like this. 1 plus sine of x, 1 minus sine of x. And you can see that it ends up working out very nicely. So this is a sight thing that you'll eventually begin to pick up over time, that this difference of squares shows up quite often. Anytime you see 1 minus a term, or 1 plus a term, or a term plus 1, term minus 1, it's something that should always be sticking out to you.